Welcome to the object-oriented lesson. This lesson is an entire web page of multiple videos, all just to cover object-oriented programming. Object-oriented programming is a dreaded and confusing topic for all programmers to have to learn. But why? Because it's not actually that hard. Why is it so confusing? Well, it's hard to teach and it's hard to learn, but once you have it, once it clicks into place, it's like, it's like one of the, it's like there's no real convenient or applicable metaphor for object-oriented programming because it doesn't super exactly reflect how the real world works. I find a lot of the sort of classic programming textbook metaphors to do more harm than good. Even the metaphors that I was taught with end up giving me an inaccurate mental model that messed up my expectations of how the code was supposed to work, and I found that very frustrating. So on that note, let me tell you how I plan on teaching this concept. Instead of metaphors and a bunch of examples until eventually it clicks into place, we're going to take things slow. We aren't quite ready to dive even into the object-oriented concepts or the actual meat of this lesson yet. First, we're going to start with prerequisite knowledge, prerequisite vocabulary terms, taking some of the more general words we've been using, giving them some concrete programming vocabulary that we'll be using. Once we have all that in place, learning the object-oriented concepts will be much simpler. After that, we'll look at the syntax in C#. So we're going to look at the C# syntax and the typing of programming separate from the concepts. And then at the very end, we'll do a big example to put it all together and reinforce everything. So the rest of this video is to cover a bunch of vocab words. I'm going to have it all written out below as well. So feel free to scroll down and read. I recommend you just sit back, full screen, watch this part, and then reinforce some of the listening with reading is the best way to learn, but you do you. So let's dive into that. First, a data structure. Data structures are an organization of data. Pretty general. When we have a collection of information that is related, we can put it in a structure that allows us to easily use, access, compare, and manipulate that data. We use data structures all the time, everywhere, all over the place, all over computers, but also in real life. Consider an address. The post office expects addresses to be formatted in a certain way, structured in a certain way, you might say, that will allows it to easily look and say, oh, this number, that's the address number, this number, that's the street number. And it can understand that thanks to the structure of it, the formatting. Data structures are they give us the content and context of information. Consider a spreadsheet. The spreadsheet is a structured format of data that gives every piece of data a row and column. It's a space in a spreadsheet. So data structures give little bits of data, the actual ones and zeros, that meaning, that context, and they let us compare similar data and work with them easily. Let's consider one more example, contacts cards, like a contact in your phone or a business card, right? Like if you met me and you needed my contact information, if I wrote my name on a piece of paper and then wrote my phone number on a different small piece of paper, then handed you both of them, and then, you hopefully kept them structured and organized in a way, but maybe that would be awful. Give you a business card, there it is, structured, formatted in one go. Or on cell phones, they have a data structure that represents a contact. You can actually share that and hit the share button next to your contact and send that to somebody, and then it'll send it all to the other phone, which can understand that. It's very easy. By the way, you can do that. Stop texting people numbers. Just give them the whole contact information. Anyway, so those are data structures, just a way of giving names, context, rows, columns, whatever it might be to data. Up next is hierarchy. Hierarchy, this is a word I'm sure you've heard before. Hierarchical. Hierarchical relationships. Relationships of a hierarchy. Hierarchical relationships are a way of organizing things. We place different things on different levels. Things can be related to each other as above another thing, below another thing, or at the same level as another thing. Things that are horizontally linked are not directly linked, but we go to a common ancestor, common parent above them, back down, and we can find the links between these objects. That's a hierarchy. In programming, we call the higher level things parents, the lower level things children, and things on the same level to be siblings. Hierarchy. Taxonomy. Taxonomy is not a programming concept, but knowing about taxonomies and having them in your mind is going to be helpful here. Taxonomy is a system of classification. Most taxonomies that you have heard of are structured hierarchies. From soil classification, a favorite of mine, to military rank, to biological rank order, domain, kingdom, phylum, class, order, family, genus, species. I read that. I don't have that memorized. And other such taxonomies. These other taxonomies exist. Programming is not just data structures, but whole taxonomies to best represent our systems that we're creating, that we are creating these taxonomies. Now that sounds very complicated, but creating our own taxonomies from scratch is way easier than creating a taxonomy that describes existing phenomenon. Classification nerds are all about describing existing things, like solving puzzles. They examine the behaviors and features and properties and determine where something fits and how they can make sense of a complex system by giving it just a nice and beautiful classification system. For me, how do I organize my record collection is a good example. Should I go alphabetically by artist? Should I go by genre or by listening mood? Or by a little most recently or things that I'm currently vibing with and likely to grab area, and then other, which is my current system. It's my 5 most recent records, and then everything else is somewhere else. It's not a good system. Or are tomatoes a fruit or a vegetable? Well, and what really is a platypus? Platypuses are mammals that lay eggs, and they have a duck bill and a beaver tail and an otter feet, and they don't make any sense. Platypuses are very confusing, and they're not important for this video because we don't need to describe this existing world. I don't need to tell you where a platypus fits in relationship to a duck or a dolphin or a beaver. Instead, I can create my own taxonomies and the things that they just do what we say. Because in programming, they're my data structures, my taxonomies, and that defines what the things are. We don't just describe them, we define them. I can create a thing called tomato, and I can have that thing inherit a fruit, or I can have that thing inherit from a vegetable, or I can have it inherit from something else entirely. It can be a fruit, it can be a vegetable, whatever I say goes. And that makes life so much easier than when we are, than the classification system. Inheritance. This one's great. I got good news for you. Inheritance for once actually means, in its non-programming word, it means basically the same as its non-programming definition. It means inheritance. Objects will receive traits and properties from things that they inherit from things that are higher above them on their hierarchy. For example, I'm a child who received from my parents an overactive metabolism, a very thin face, and a love for the smell of coffee. Although that last one may not be genetic. Unlike genetics and programming, objects will receive all of the things from their parents without random mutation, which is good, because imagine programming with random mutations involved. That would be a whole thing. You know what? There is that. It's neural networks, kind of. Members. I've been very loose with my vocabulary so far, and I've been using the word thing a lot. An object inherits things from its parents. But in programming, we have a new word for thing, member. An object is made up of its members. Its variables are the members. Its functions are also the members. So both variables and functions are members. Members is sort of the broader term for all the different things that an object can have. So thing isn't a very useful word. We're going to be specific, and from here on out, I will be using the word member. And again, it's not just variables and functions, but although those are the main things. Members can be fields, variables, constants, properties, methods, functions, events, operators, indexers, constructors, deconstructors, finalizers, and nested types. And yeah, we may not have learned what all of those words mean yet, but they are just different things in C# programming. Features that we'll get to eventually, or we may not get to, who knows? Some of them aren't as important. A class's members are all of its data and its behaviors. Scope. We're going to have a deeper lesson on scope in the future, and we've also already touched on scope quite a bit. We've touched on access scope because it's unavoidable in programming. Public, private, do those words sound familiar to you? Scope is members, public and private members. It's a property that members can have. Is it scope? And it determines how other things that are elsewhere can access or see. This object-oriented programming lesson is going to give us insight to what I mean by elsewhere and things that are other and on the outside and the inside. So we're going to circle back to that later. We're going to come back to scope in a more There's a mouse in my ceiling. I'm going to come back to that mouse later, and we're going to come back to scope later. One final piece of vocabulary that's very important from keeping ourselves from getting too confused is a reminder from our architecture lecture, which is a way of programming that allows us to get past a lot of the shortcomings of object-oriented data structures. And it's called component-based architecture. Component systems. Component systems are a way of programming with reusable and independent blocks of behavior that we can add and remove from an object, like mixing and matching and making up making up behaviors. Unity uses a component system. Unity's components are its component systems, and those go on game objects. All of our components have inherited from mono behavior. All of our components have been siblings to each other in the hierarchy that the Unity engine uses, and that's why we haven't actually learned too much about object-oriented programming yet. Components are not a feature built into C#, but rather they are a way that Unity engine uses and structures and organizes its programming, its code. And that's it for vocab. That's not it for all the vocab you'll ever learn, but that's it for what we need to cover before getting to object-oriented programming. And at this point, you might even be able to take an educated guess as to what we mean by object-oriented programming. It's inheritance. We mean it's inheriting things and how we can organize our code to inherit behaviors. So I'm going to end this video here, and you should review the vocab, and then I'll see you. I mean, for me, in just like 5 seconds, I'm going to keep talking, but I'll edit this part out. Maybe I won't. No, I'll edit this part out.